All right, only 2 more lessons in this chapter. So we are 2.5 graphing techniques and transformations. So our first transformations are shifting left and right or up and down. And so vertical shift, that's when you have a change in the y, and it's whenever you have something like outside of the parentheses. So plus k, you move up that many units, minus k, you move down that many units. Whenever you have something inside the parentheses, this affects your change in the x. So if it's plus, you're going to actually go minus that many units. If it's minus h, you're going to actually go plus to the right that many units. So here we're going to graph our function and then determine its domain range. So first I'm going to graph its parent function of x squared. Then I'm going to do the x minus 3 squared in blue. So I'm going to go actually plus 3 in the x direction. And then my minus 5, I'm going to move 5 down in the y. So here, and then graph. So our purple one is the final graph. The domain, it includes every x value. So the domain is all real numbers. And then the range is from -5 up. So our range is y is greater than or equal to -5. Then we'll go over dilation. So you can either like stretch or compress. So either make it like thinner or make it wider. And then we have, so either way. And then we're going to do some examples. So we have this graph that we're given, and we're going to use this graph to find the graphs of y is 2f of x. So the 2 is in front of the function, so that means we have a vertical stretch, and we're going to multiply y by 2. So when it's in front of the function, we have, and it's a whole number, we have a vertical stretch. Oh, I cannot spell again. S-E-R-E-T-C-H, vertical stretch, and multiply each y by 2. So we're going to take those points and multiply each y value by 2. So our origin still stays the origin, but that pi over 2 comma 1, 1 times 2 is 2. So now it's going to be pi over 2, 2. And then pi, 0. 0 times 2 is still 0. And then 3 pi over 2 comma -1. -1 times 2 is -2. Then 2 pi. Then we have 5 pi over 2 comma 2. And then 3 pi. And connect our points. I'm going to shrink this so we can do our next one. New is going to take the y. You just erase it and add it back in. Alright. I see it erased those too. Alright, so next we have y equals f3 of x. So since the 3 is on the inside, it is a whole number. So our a is greater than 1. So that means we have a horizontal compression. And we're going to multiply every x value by 1/3. So you're doing the opposite. So multiply every x by 1/3. So I'm gonna start our graph. 0, 0 stays the same, but pi over 2 times 1/3 is now pi over 6. So I'm just gonna pi over 6, 1. And then pi is now going to be pi over 3. And then our 3 pi over 2 times 1/3 is now pi over 2. Then 2 pi becomes 2 pi over 3. And 5 pi over 2 times 1/3 is 5 pi over 6. And then 3 pi becomes pi. And then there's that graph. Next, we have reflections. So x-axis reflection is when the negative is in front of the function. Y-axis is when it's inside, and then you just flip it based on which reflection you have. So find the function that is originally graphed after the following 3 transformations are applied to the graph. So first, we shift left 2 units. So that means we have inside the parentheses, if we're shifting left, we actually do the opposite. So it's going to be x plus 2. Then we're going to shift up 3 units. So that's our outside value. So y equals the absolute value of x plus 2. And then this is the same, so plus 3. And then reflect about the y-axis. So inside the parentheses, our x is going to be negative. So y equals the absolute value of negative x plus 2 plus 3. Okay. We're going to graph this function and find the domain and range. So our parent function of this function is y equals 1 over x. So we're going to use that to base off the transformations that it has. And I'm going to change this a little bit because 3 over x minus 2 can be written as, I'm going to change it, 3 times 1 over x minus 2 plus 1. So we already know our parent graph. So let's talk about what the 3 does. So y equals 3, 1 over x. We're multiplying f of x by 3. Then if we had the x minus 2 in the bottom, so y equals 3, 1 over x minus 2, that minus 2 in the bottom actually shifts this right 2 units. Alright. And then lastly, our plus 1. That plus 1 moves up 1 unit. Okay, so let's go ahead and graph it. I'm going to again start with our original function and then apply each transformation. So I'm going to make this smaller so it gives us more room for our graph. That's good enough. Draw our graph over here. So I'm going to start with our parent function, and I'll do that in black. Okay. Next, I'll do the multiply everything by 3 in pink. And it doesn't really change the graph all that much. It's just going to maybe give it a more steeper slope. And then our moving right 2 units, I'll do in purple. So I'm going to move it over right 2 units. And then lastly, our shift up 1 unit in blue. So I'm going to shift it up 1 unit in the blue. And the blue then is our final graph. Alright. Lastly, we're going to figure out our domain and range. So the domain, we shifted this right 2. So usually our domain here was that it couldn't equal 0. But now since we shifted it right 2, our domain is that it can't equal 2. And then our range, it's usually y can't equal 0. But now we shifted up 1. So y can't equal 1. And then our last question is graph the function, the square root of 1 minus x plus 2. I'm going to rewrite it so it shows our reflections a little bit more. So y equals the square root of negative x plus 1, and then plus 2 on the outside. So our parent graph, parent, is y equals the square root of x. Then we have the first transformation of y equals the square root of negative x, and that reflects over the y-axis. Over y-axis. Then we have y equals the square root of negative x plus 1 and plus 2. We'll just do both of these transformations together. So we're going to shift left 1 and shift up 2. And then we'll graph it. So our original square root function looks like this. And we'll reflect it over the y-axis in blue. And then in pink will be our final graph of shifting it left 1 and up 2. So left 1, up 2. And there's our graph. The pink is our final graph. So lastly, domain and range. So the domain, it goes from negative infinity, but it stops at that negative 1. So from negative infinity to negative 1. And then the range, we have from, it started at 2 and it goes up, so 2 to infinity. And that's it. Let me know if you have any questions.